We will move along into more specific things about human evolution and how that is related to health as well. In the last podcast, I left off here about how COVID-19 mortality is being confounded or being maybe exacerbated by exposure to pollution, PM 2.5 and so on. As we build up towards climate and health and human evolution from Cambrian to the first farmers, let's look at a couple of more points. This is showing northwest wind speed in Japan in meters per second and the Kawasaki disease in Japan. The exact cause of Kawasaki disease is not well known, but it is understood that when the dust and winds bring more dust or less dust, the bacterial loading and the exposure also changes. So you find these kind of strong statistical relation between westerly wind strength, winds coming from the west, China, Mongolia onto Japan, and rates of Kawasaki disease in Japan during 1996 to 2006 by month. Kawasaki disease especially high in Japan. So all these things remain kind of to be understood, but empirical relations help because you can take protective measures by using predictability in the winds. So if winds are predictable, then we can say the probability of Kawasaki disease may be high, so then early warning systems and protective measures can be taken. That's where many of the things are headed, and that's where community health and individual health kind of become one management system in terms of getting the system ready and providing information for people to take care of themselves. This is other example of the bimodal responses to temperature change, so-called Goldilock zones for two critical biological components of malaria transmission in relation to temperature. So you can see the pathogen development rate per day. So that's rate of development of Plasmodium within the mosquito itself has this inverted U shape. This kind of shape appears in many places. I won't go into the details, but often it becomes what is called Kuznets curve in some instances of environmental damage versus per capita GDP and so on. So here we are looking at temperature degrees Celsius and the pathogen development in rate per day. Development rate per day. So you can see that at colder temperatures it drops off, increases up to some optimal temperature, and when it gets too hot it again drops off. We saw this kind of behavior before. And this is survival probability, so daily probability of mosquito survival, which also has a similar downward facing U curve, increases up to some optimal temperature and then drops off. Again, these are relations that can help us. This is now the relationship between late spring normalized soil water balance, a function of temperature and rainfall, obviously, and barley yields in Czech Republic during the past century. The dashed curve is the 5-year running mean, so it's a low frequency signal. Running mean deviation in yield from the average value in the normal range. So barley yield variation, and here we are looking at water balance as a function of rainfall and temperature for April and June. And again you can see there are many years of data here going from 1950 or even back to 1922 here. And there is the normal range here in terms of water balance index, and then you have dropping on either side of this optimal region where you get too wet or too dry. So what is the context? Essentially, over time climate has changed and humans survived on hunter-gatherers for a long time, and they at some point long time ago mastered fire and ate cooked meat, which are high in protein, affected both the gut and the brain. Most humans, especially when you are young, brain it uses up lots of the energy. As an adult should be about 25%, but as an infant it could be as high as 60%. So the impact of shortening the gut and easier digestion, etc., would have affected the energy supply to the brain as well. So there has been this relation between human evolution, diet, and of course health. We will see that as we adapted to agriculture, there were some negative impacts of agricultural lifestyle as well. So that should allow us then to transition to this chapter on Cambrian explosion to first farmers, how climate made us human. Tony Michael goes into details about the evolutionary aspects of which are fun to read, but I'm not sure I'll spend too much time here. You can read about it in the book or elsewhere as well, because Tony is summarizing it as a epidemiologist, not really as an evolutionary biologist. So he's reporting from other papers as well. But to bring us to context, here we are. We looked at this before, where we went back to Paleocene, Eocene. We talked about the thermal maximum. We will look at some extinctions that happened going back even further, and then the cooling that happened over the last 50 million years. There are many hypotheses. One of the ones is that especially in the last let's say 30 million years or so, India crashed into a Eurasian plate. The Himalayas rose, exposed a lot of new material. Monsoon got set up over time, probably reached its current strength around 10 million years ago, and that would have drawn down a lot of carbon, CO2 from the air, and that would have allowed this kind of cooling as well. And there is of course orbital forcing mixed in with that, and you can see these time scale changes along the way, especially a switch from the obliquity time scale of 41,000 years to the eccentricity precession time scale of there is a combination of the two actually. Precession is 23,000, eccentricity is 100,000, but eccentricity related radiative forcing is not too big, so you need some explanation there. That happened in the Pleistocene, where we had these 100,000 year time scales, and we obviously evolved, our ancestors, and then we as Homo sapiens evolved around let's say a couple of 300,000 years ago, and then we will look at more specifically coming into the Holocene at the end of the last glacial maximum and the start of the modern human being as agriculturalists, and we are of course worried about where we are headed. So these kind of climate change, especially this cooling over these 50 million years, fairly significant cooling, and the warming is with reference to that, of course, coming out of the cooling, and whether it would have continued and whether we changed the trajectory and how much we will change it and so on are important points. But this kind of climate change and human evolution has been mixed with, of course, evolution of other species, especially vegetation, their migration, biodiversity, latitudes, and so on. This shows the maximum biodiversity, which in the past was focused around the Mediterranean. Right now it's focused on in the tropics, which on land may make sense because of rainforests and the heavy concentration of species there, but even in warm ocean waters where nutrients are generally depleted, you get high biodiversity because they are home to corals, and corals are like the rainforests of the ocean, very efficient at recycling and supporting lots of biodiversity and so on. So that interaction between biodiversity overall and human evolution obviously are related to each other, along with the health aspects. For example, over such long time scales, there's been the evolution of the louse, which has adopted from various animals like rodents and baboons to humans, and typhus was a major killer at some point, but not anymore. So lice made home in human hair, human clothing, human fur, etc. And now that's not such a big concern, especially in developed countries. Okay, so let's leave this podcast here and continue in the next podcast, but we will add details about evolution of life in general, humans in particular, and then transition into specific health aspects along the way to give us this, as I said before, big history perspective on where we have come from in terms of our interaction with climate and health.